We'll move on to the ellipse. The standard form of an ellipse, x minus h squared over a squared plus y minus k squared over b squared equals 1. That a squared underneath the x, that is going to help us find the horizontal stretch, and the b squared under the y is going to help us find the vertical stretch. Okay, the horizontal shift, that's going to be right here. It's the opposite of h. The horizontal stretch, right there. Okay, the vertical shift, that's going to be represented by k. The vertical stretch, right there. We could also find those in this equation, which is the same except the y and the x are switched. Sometimes people like to have an ellipse that's more horizontal with the x first and more vertical with the y first. But since it's addition and that's commutative, we really don't even need to use that. It will work, but we don't necessarily need it. Okay, so here is an equation of an ellipse that we are going to graph. So x minus 5 squared. That minus 5 tells me that this is being shifted 5 to the right. And that plus 3 here tells me 3 down. So that tells me the center. So the center is HK. And what's in here is the opposite of H and K. So the center of this ellipse is 5, negative 3. So over 5, down 3. Okay, then it has a horizontal stretch. Down here is 4, but remember in the equation, it said a squared. So that means the horizontal stretch, or the horizontal dilation, is another word for that, and it's one we actually use more often. So I'm going to put a D. The horizontal dilation is the square root of 4, which is 2, and the vertical dilation is the square root of 16, which is 4. So that means that this ellipse to the right and the left goes 2 from the center. And up and down it goes 4. So the ellipse looks like that. Okay, so here's an ellipse that we are going to find an equation for. So to find an equation, we need to know the center, and that would be negative 3, 2. Okay, so we've got the center, now we need the horizontal dilation. It goes 1, 2, 3, 4 to the right and left. And the vertical dilation, 1, 2, 3, 4, 5. So for the horizontal components, we've got x, and then there's a negative 3, so x plus 3 squared over the horizontal dilation squared, 4 squared is 16. And then we have a 2 for the vertical shift. So that would be y minus 2 squared. And the dilation 5 means 5 squared goes here, 25, all equal to 1. Now we notice that the horizontal and vertical dilations do not equal each other. 16 and 25 are not the same. That's why this is not a circle. That's the only thing that separates an ellipse from a circle. Horizontal and vertical stretch are different. Okay, here we have a center of negative 1, negative 3. A horizontal dilation, 1, 2, 3, 4, 5, 6, 7. And a vertical dilation, 1, 2, 3, 4. So for the horizontal components, x plus 1 squared over 7 squared is 49. And then for the vertical components, y minus 3 squared over 4 squared, 16, equals 1.